Hi, I'm Ben, and this is the house I built out of shipping containers. Now, I've been interested in shipping container architecture for quite some time, but I had a really hard time finding good information about how to get building permits or how much would it cost. Well, we did the research, we documented everything that we did, and now we're so excited to share with you what we learned. So check it out.
This is episode 2, where we'll show you how we moved the containers, cut them open, and started the structural reinforcement. After letting the concrete cure for 3 days, we began stripping the molds and getting ready for the day I was most excited about, which is Crane Day. This is the single biggest piece of equipment that we rented for this project, and it's basically like a giant transformer. To pick up the containers, they use these fabric straps, which are super strong, and each one of them has a hook which can hook into the boxes at the corner of the containers. We started by moving one of the extra 20-foot containers that I bought to store tools and materials on site. This is a specialty type of container that opens up not just on the short sides, but on the broad side as well. Next, we started moving the other 20-foot container, which is going to be the guest bedroom and bathroom. This container is lightweight enough that the crane could actually drive while the box was suspended in the air. We had to line up the container so that it wouldn't break one of the drain pipes that was sticking through the concrete. Next up was a 40-foot container, which is too heavy to drive with. So what they did is they just would pick it up, swing the arm around to get it closer, and then reposition the crane and do the whole thing again. We put some blue painter's tape on the corners of the concrete foundation just to give us a mark to aim for. The second 40-foot container had the farthest distance to travel, and it's sort of like watching an inchworm sort of move its way across the desert. It took a few attempts and 3 guys pushing on the corners to get it in the right location. Now, if I was designing this again, I would now know that it's possible to get it not exactly where you want it, but within about half an inch. Crane Day was a lot of fun, but now it's time to turn these steel boxes into a house. We started pulling up the floors on the containers. Now, these floors are made out of plywood that is about 1 1/8 of an inch thick. The steel structure underneath and the underside of this plywood is coated with a thick black tar-like substance, which is there for waterproofing and to keep the steel from rusting. The majority of the plumbing for this house is going to go in this layer, right amongst all the steel beams. And of course, things never line up properly, so we're going to have to cut out a few of them. Now, the pipe that Robert the plumber is working around is going to be the main drain that goes out from the container to the septic tank. Originally, we had left this a lot longer, but once we saw that it wasn't going to align perfectly with the structure inside the container, we had to cut it down so it wouldn't break when we dropped the container into place. This meant that Robert would have to use a jackhammer to expose a little bit of the pipe by removing some of the concrete, so we'd have enough room to fit an elbow on it. Now, when I first learned we'd have to do this, I was worried it would take a really long time, but it actually only took about 45 minutes. We then cut holes in the other beams so that we could run the smaller drain pipes, which will receive the water from the bathroom sink, the shower, the toilet, and the kitchen sink. The cut edges of the steel are quite sharp, so the plumbers put some 20-minute hot mud and spray foam in between the pipes and the steel beams, just to keep the pipes from sliding around and potentially getting damaged. Now, wherever you have drains, you also need to have venting pipes, and these go all the way up through the walls and out the roof. Now, the black ABS pipe is fine for wastewater going out of the building, but for all the clean water coming in, we want to use copper. This was more time consuming because the copper has to be sweated with a torch, whereas the ABS plastic pipe can just be glued together. Now, in the floor areas that don't have pipes going through them, we started filling those places in with rigid insulation. We packed in 2 layers of 2-inch thick rigid insulation and then used spray foam to seal up all the gaps. Even though this insulation has an excellent R value, it's not going to be super effective in this location because the conductivity of the metal is going to create a thermal bridge around it. But still, we added it in to keep that space full, keep critters out of it, and to just give us a little bit of extra thermal protection. This foam insulation cuts pretty easily with a box cutter, so we just cut pieces that would also fit around all the pipes. After sealing it all with spray foam and testing to make sure the pipes are watertight, we then put the floorboards back on. This installation is just so we can cover up the floors and get to work on the framing. We'll show the full installation details, including how we did continuous insulation over this plywood, in next week's episode. While the rest of the crew was working on the insulation and the floors, I began making the structural frames for the doors and windows. After double checking the dimensions of the windows, I began making the 45-degree cuts so that I can make a mitered frame. The shipping container gets its strength from the continuous corrugated panels, so whenever you cut one of these panels, you have to reinforce it. For these first few windows, I decided to use 2-inch tube steel. It works great and is plenty strong, but as you see for some of the later frames, I switched to angle sections. Now I did all the welding for the doors and windows using this little Forney welder. It's an inexpensive machine that's easy to use, great for beginners, and powerful enough to build a house with. And now for the moment of truth. I was ready to cut into the container for the first time. Now I was pretty nervous about this because, I paid a reasonable amount of money for these things, and we had spent all this time to get them in the right position, so I really didn't want to screw this up. I drew out the square that I'm going to cut out that will allow the frame to fit in using a silver Sharpie, a level, and a piece of cardboard so I could draw straight lines around the corrugation. We didn't have electricity from the grid available on the construction site, so I set up one of my little Goal Zero power packs with a solar panel, and that was enough to keep my batteries for my battery-powered angle grinder nice and charged. Now, I'd seen people cut containers open using a plasma cutter, but I'm really accurate with the angle grinder. It's a much easier tool to use and less expensive. I just went slow, made sure that I was following along the lines. I went through quite a few discs, but it only took about an hour and a half to cut out this entire window. The paint on these containers is really thick, so I wire brushed it away to expose the bare steel in preparation for welding. I needed a way to hold the frame in place while I welded the frame to the corrugated metal. So I built these sliding supports out of 2x4s that would allow me to clamp the 2x4s to the corrugation and hold the frame nice and flush to the corrugation. This is important because when you cut into these big panels of corrugated metal, they can bow and flex quite a bit. With this technique, it's pretty important that the hole you cut into corrugated metal is just the right size because you don't want to be having to bridge across with the welder to connect the pieces. You don't have to do continuous seams all the way around. I just tried to get about 2 to 3 inch welds about every 6 to 8 inches. I screwed up an overcut on this piece, but I just filled it in with my welder. The second one went a lot smoother. I took more time in making sure that my initial drawing on the container was perfect, and I went a lot slower with the cutting as well, making sure to stay right on the line. It was about 120 degrees inside these steel boxes, and cutting open the window was a great experience. Not only you get to see the view, but you get this rush of cooler, just 105-degree air coming in. It's definitely worth it to go really slow and get your initial cutout as accurate as possible. The welding for this second one was a lot easier because I wasn't bridging as big of a gap between the frame and the corrugated steel. On the first window, I ended up making seams that were a little bit too long. On the second one, I kind of got it right and was sticking to seams that were just about 2 to 3 inches long. If you try to weld seams that are too long and continuous, the heat buildup from all the welding can start to deform and bend the corrugated metal. For the two big 10-foot long bifolding doors, I wanted a frame that was a little bit stronger, so I went with 3-inch by 2-inch tube steel. I glued some blocks of wood to the underside of a steel square, and then I used that to clamp my tube steel pieces at nice right angles. I learned that grinding things once they're installed is a little bit more difficult, especially if you have to get up on a ladder, so I made sure to grind out all my welds as I welded them. Now the frames for the doors don't need a bottom piece, but I didn't want to move this without one because it might bend, so I just welded in a temporary support. I also didn't cut the vertical pieces to length until I had welded the whole thing together. This way I could make sure that both sides were even. Working close to the ground is great because you can keep everything nice and flat, but it did make it so that we'd have to flip the frames over in order to cut all the way through from the other side with the angle grinder. First frame is done, time to make a second one exactly the same. For these big doors, we started cutting out the openings from the inside since it was easier to get up on a ladder with the nice flat floor. Black Sharpie lines showed up real strong against the light beige interiors, so it was easier to cut from the inside because I could see the line really crisply, even through all the sweat and fog on the safety glasses. No matter what side you're in though, it's easier to cut the part of the corrugation that's closest to you, so I did do some of it outside as well. It's also easier to cut real close and flush to the support beam from the outside, because from the inside, it's hard to get the angle grinder at the right angle because the floor gets in the way. Now, one thing to be careful for is that when you're cutting the container, the walls are under some pressure, and all of a sudden, every once in a while, they will jump or move, and this can pinch the angle grinder or snap off a blade. These big pieces of metal are bendy, heavy, and have jagged edges, so it's a little bit tricky to handle them without cutting yourself up. Some containers have welded-on steel loops that are used to strap down cargo. I just cut these out as well. The corrugated metal was welded to this base beam along the container. I switched to a heavier angle grinder and just ground this all down. I stripped away the paint in preparation for welding, and we lifted this 10-foot by 7-foot frame into place. Remembering the lesson from the windows about bridging the gaps, we cut a little bit more on the conservative side, and it wasn't quite big enough, so we just ground away until the frame fit in perfectly. We started by tacking the frame to the base beam at the bottom corner, and then slowly worked our way up, making sure everything was still level. The 3-inch wide tube steel was a lot easier to weld to the corrugation than the 2-inch steel because there was just a lot more surface area to connect the welds to, and the radius of the tube steel wasn't sloping away from the corrugation. As soon as I got the frame tacked in and secured to the container, I cut away the temporary support. In retrospect, I should have welded this about 6 inches higher than I did just to give myself a little bit more room to cut it off. So while I was welding in the first frame, the guys started cutting the opening for the second one. Now you might think that shipping containers are quite strong and don't need any additional structural support, but that's not actually the case if you're doing a fully permitted, code-approved building. Our structural engineer had to design an interior support system out of 2x lumber and plywood that would meet all of the structural requirements from the permitting office. This required substantial headers over these large bifolding doors. We were figuring this out as we went along, and we knew that the doors and windows would be the trickiest parts, so we made sure to frame around those and get that all set relative to the drawings before filling in all the wall spaces around them. Once you have the key structural elements in place, using a nail gun to add in 2x4s isn't too hard. On most of the projects that I've been involved with, the header is directly over the door itself. But in this case, the header has to be tied in to the square steel tube that runs along the upper length of the container. And so therefore, we had to push the header up and then frame out underneath it. The purpose of the header is to provide support over large doors or windows. You don't want deflection down onto these frames, which could either cause them to break or could make them very difficult to open. The framing was going pretty quickly, but nothing was really tied into the container yet, except for the 2x4 that runs along the bottom of the wall that was attached to the plywood that is part of the container floor. The stretches of walls that don't have doors and windows or plumbing features went a lot faster because we could panelize and build the walls in sections outside. We could then drag these into the container and then shoot nails down through this bottom 2x4 or sill plate and into the plywood deck below. Now, I've had a lot of people ask why any sort of additional structure is needed. I mean, aren't these steel boxes? Shouldn't they be strong enough by themselves? The problem isn't that these boxes aren't strong enough, it's where they get their strength, and it's from these continuous corrugated panels. That strength is compromised when we cut into them, even though we are reinforcing where we cut. But the more important problem is that this steel is exposed to the outside, and it's only about 1/8 of an inch thick. If you're relying on exterior steel that's relatively thin for the structural support of the building, if someone doesn't maintain the paint and it starts to rust out, the whole building could collapse. You don't really want buildings that can have structural failures just due to owner neglect. The most annoying part of the framing was attaching the walls to the steel containers. We nailed these galvanized steel brackets to a 2x4 and then nailed this on top of the walls to create a double top plate, and then drive self-tapping screws through the holes in the brackets and into the square steel tube that runs along the top of the container. Now, putting this many self-tapping screws into steel is not fun, and this took a minute. Our walls are taller than 8 feet, and we're going to have to add plywood sheathing. So we added additional pieces of 2x4 in between the studs so that we'd have a surface for nailing on the plywood. The ceiling will be supported by 2x4s on joist hangers. We didn't nail in the 2x4s yet because we still have to add insulation and sprinkler systems and other things, but we just cut them and set them in place for now. So to recap, we have a 2x4 at the bottom, vertical 2x4s with stiffeners, some additional pieces for attaching the plywood and eventually drywall, hangers to support the 2x4s that'll support the ceiling, a double top plate, with brackets attached to the container. Another tricky structural requirement was that we had to tie down some of the shear walls to the foundation. We have to have a steel rod coming up from the concrete. Now, we can get in there one of two ways. We can either cast it in place and use a coupling nut, or we can drill a hole and epoxy it in there. But in either case, it has to come up through the container, through a top plate, where this galvanized steel bracket can be bolted to it, and then that bracket can be attached to a 4x6 or 4x4 post. So Tony wrestled with that, but we didn't want to lock the post in place until we knew how the window installation would go. After cleaning all the welds with wire brush, I then sprayed a few coats of rusty metal primer over the welds, the exposed steel that I brushed away on the container, and the frames themselves. We ran a heavy bead of caulk around the inside of the frame and then pressed the window into place. The nailing flange on the window is going right up against the inside of the frame, and then we drove self-tapping screws through the flange and into the steel frame. Now, this wouldn't be an ideal building detail in anything but a dry climate like this because you really have to rely on the silicone caulk from the exterior between the window unit and the steel frame to be your rain protection. With the window in place, Tony then felt comfortable adding in the post. So here's how the whole framing for this end wall looks. We have a steel rod going into the foundation that attaches to a bracket that connects to a post, which is tied into the rest of the 2x4 framing. I recommend drilling holes and using anchoring epoxy to fix the steel rods into the concrete. It's way easier than trying to cast them in perfectly. Now, you may have noticed that the part of the floor that the steel rod went through was steel. And that's because this is part of the container where forklifts can come in to lift up the container from the end. You may notice that our building details are different throughout the project, and that's because we were learning as we went. The frames I made out of tube steel for the first set of doors and windows worked just fine, but I noticed that it was very difficult to hold them perfectly in place, and it was a really unforgiving detail where you had to cut the window hole perfect. So for the next set of doors, I used angle steel to make the frames. This way I would have a flange that could catch on the hole in the container, which would make it easier for clamping, getting it straight, and it would give us a little bit of an overlapping connection where we could caulk it from both sides. I used an angle grinder to notch out the ends of these pieces of angle steel so that they'd fit together and have a nice flat flange. These frames are going to reinforce the openings for the swinging entry doors. I welded the corners, added a temporary support piece, and then flipped the frame over and welded from the other side. The 20-foot container, which is going to house the guest bedroom, has two swinging doors that are parallel to each other that's going to create opportunities for cross ventilation. My buddy Eric was visiting, so we had ourselves a dueling angle grinder situation. Eric is a really talented metalworker, and be sure to check out his work. I'll put a link to his Instagram in the description box below. I feel like this is a much better way to frame the doors and windows. Not only does the flange catch nicely on the corrugation, it actually gives you a really clean aesthetic from the outside as well. You also get two different areas to weld the frame to the corrugated metal. On the outside, you weld right along the opening. But on the inside, you're welding the edge of the flange to the surface of the corrugated metal. It's also nice because it gives us two seams to caulk, one on the inside and one on the outside. I'll show finished drawings of the different window framing details next week as I show how I finished trimming out all the windows and doors. And also in the next episode of the Modern Home Project, we'll show how we did the insulation, installed the doors and windows, and start having a little bit of fun along the way. Be sure to check out the first episode, and don't forget to subscribe and turn on notifications. Oh yeah, and our new website's up, so check it out. We'll still be adding more information as we go, but it's worth taking a look now.